Hi, good morning everyone. So, the given question is link A, B and C. The question is requiring the answer for instantaneous center of zero velocity of bar BC, which we can denote as SIC, and the answer for velocity of slider block C, which we denote as VC. So, let us go to the given info in this question. It is given that the link AB has a radius of 0.2 meter, while link BC has a radius of 0.5 meter. It is given an angular velocity of 6 radian per second in link AB, which has a 45 degree of angle, and link BC consists of 10 degree of angle. So, the first thing that you have to do to solve this question is draw the FBD of this diagram. So, first we draw link A to B, A, B. Then link B to C. Okay. So, from A to B, there is an angular rotation of 6 radian per second. Okay. So we know that velocity must be tangential to the angular velocity. So we can draw the VB as going upwards. So we draw VB as going upward. Why we draw VB as going upwards? There is a theory that states that velocity must be tangential to the angular of rotation. So that's why we draw VB towards upwards. And another cause is the angular rotation is anti-clockwise. So the velocity direction will be upwards. Okay, now in link BC, since the link AB moves anti-clockwise, the block C will move from right to left. So we assume that the velocity of C is moving toward left. Okay. Here we draw a length of C which must be perpendicular to VC. This is C. We denote this as length of C. Okay, now VB must be perpendicular to the link. Therefore, we draw another line here. So, we will find out an intersection between the line B and the length of C, where we denote this as the IC. IC is where the intersection of 2 points, which we denote as instantaneous center of zero velocity. And now we can proceed to draw the angle given. So here we know that it is given 45 degree and here is 10 degree. So this is 90. Here would be 80 degree automatically. And here it is 45. It is 45 too. So here 180. The simple triangular circulation, 180 minus 80 minus 45, you will get 55. So it is 55 degree over here. And given 0.2 meter here, and it is 0.5 meter here. Okay, since we have all the angles, we found out all the angles. Now we have to find out the length of C to IC and B to IC, so that we can find out the velocity of C. To do that, we need to use cosine rule to find out the length. Since there are all of the angles is provided, we have found all the angles. Now we can use cosine rule to solve this question to find out VC. So we are using cosine rho. Okay, ignore my bad handwriting and my lines. It's not straight, I'm sorry. Okay, for cosine rho. Now, BC, since we are taking BC, we should take the opposite angle, which is 45. So, sine 45 equals to C to IC, the opposite angle will be 55, so sine 55, and B to IC, so the opposite angle will be 80, so sine 80. Okay, now to find the length from C to IC, okay, we have the length of BC, which is 0.5 meter. So 0.5 meter sine 45 equals to CIC sine 55. So we just switch the formula and we will get 0.5. Now if we calculate 0.5 over sine 45 sine 55, so we are getting 0.5792. It is better that we take any answers to 4 decimal places. It will be quite accurate when we get the answer. Okay, now move on to find out the length of B to IC. The same formula, the same method. So 0.5 meter over sine 45. So divide by sine 45 times sine 18. So we are getting 0.6964 meter. Now we have found out the radius for B to IC and C to IC. Okay, the next step would be we have to find the velocity of C. So now, as we know, the theory is to find velocity, the formula is V equals to angular velocity times with radius. Okay, first we have to find velocity of B in order to find velocity of C. So VB equals to omega AB times RAB. So we have angular velocity of AB, which is 6 radian per second, times of radius AB, where it is 0.2 meter, and we'll get the answer of 1.2 meter per second. So we have found out the velocity of B. Okay, now in order to find the velocity of C, we need to find the omega of BC. Okay, to find omega of BC, we use VB equals to omega BC times RBC. So VB 1.2 omega BC times RBC, as we found just now, 0.6964. So omega BC equals to 1.2 over 0.6964. So we'll get the answer 1.2 over 0.6964. 1.7231 radian per second. Okay, now as we have found out the omega BC, it would be easy for us to find the velocity of C. Omega BC times RBC. So omega BC is 1.7231 radius per second times RBC is 0.5 RCIC. Where is it? We found just now. 0.5792. 5792. So we'll get the answer 0.998. 0.998 meter per second. So, hence we have found out the answer for velocity of c and the instantaneous center of zero velocity of bar BC. That's all from me. Thank you.
This is the solutions for question number 8. This is the free body diagram of flywheel. This is the information that extracted from the question. And question number A is about moment of inertia. This is the formula of moment of inertia. And we substitute the values in to get this answer. For question number B, here we are finding the kinetic energy. Initially the flywheel is at rest, that's why T1 is equals to 0. So we find the T2 by using the formula of half IO times by angular velocity. Then we substitute the values in to get 1.8 angular velocity.
In question C, we have to find the work done of top M. So we have to integrate the moment from 0 to 10 pi. 10 pi is because of it rotates 5 revolutions. 1 revolution is equal to 2 pi. So 5 revolution is 10 pi. Then we substitute the value. Then we get the answer. For D, we have to find the angular velocity by using principle of work and energy. This formula. We substitute the value that we get and we get the answer 24.23.